Hello, everyone. My name is Chidowere Jombu, your presenter. We are going to continue with our power system studies. Today, we will look at classics of electric power, how they are categorically arranged so that individuals, companies, parastatals who want to make use of them can easily make their choice. We'll start by classifying under sources. Sources. We have sources as one. Another classification is classification based on applications. Two, applications. Then we have three, classification based on phases, number of phases. Then we only have classification based on voltage ranges. Voltage ranges. So electric power system can be classified under these four sources. We'll now pick them one after the other. Let's look at sources. Under sources, we have one, direct current power. Two, we have AC, which is alternating current power. So under sources now, we have one and II, which is direct current power and alternating current power. So on DC power, what is DC power? Direct current power is the power gotten from voltage and current flowing in one direction. Voltage and current flowing in one direction. So this defines the DC power, the kind of power where the voltage and current flows in one direction. For example, in this diagram, you can see, assuming here is our IV, this is our function of time in seconds, then you can see the kind of flows in a very straight line, and you can see that it's on one direction and it's not sinusoidal. Okay, and where do we apply it or where do we use it? We use it in, for example, in solar systems, solar batteries. You can see the conversion which we do these days because of deregulated power supply in the country now. Most people are going on solar energy. So that's the kind of power we derive from that very particular place. Then let's go to two. Two is AC power. AC power is the one which we normally use in residences and other building purposes or functions. And the AC power is that kind of power where the voltage and current flows in sinusoidally. It flows sinusoidally, meaning that it changes direction periodically. For example, with this our drawing again, you can see if you have our IV here, then this is our time. You can see it flows this way, come this way, come this way, come this way. So this is a sinusoidal flow. We can say it's oscillating. It's oscillating. So this is what defines an AC power network. So as you see it here, what it means is that they don't maintain one particular direction. Then two, we'll go by application now. By application. Classification by application. Then classification by application, we have one, reactive power, and another name for reactive power is the actual power, or if you don't want to call it actual power, you can still call it the active power. So real, active, and actual almost mean the same thing. They are synonyms. So they define each other the same meaning and the same everything. So we have by application now, we have real power. The next one we have as number 2 is our reactive power. Then the last one is the apparent power. Okay, if we should take them one after the other, we now have that our real power is the actual power which we consumed in our appliances. The actual power that dissipates or that develop in our electrical circuit. So, and is given mathematically as power P is equal to I squared R and is equally measured in watts. The real power, actual power, active power, they are measured in watt, and we say they are the power developed in the resistances of our circuit as a result of dissipation of energy. So mathematically we can now say that active or real power or actual power is equal to I squared R, which is equal to I V cos theta, which is equal to IV cos theta. So this is our real power. Then we go to our reactive power. We go to our reactive power. So on our reactive power now, this is the power developed in inductive circuits or inductive reactance. So we now put that reactive power is equal to Q, which is equal to IV sine theta. IV sine theta gives us our reactive power. So we say that it's power developed in inductive circuits. There are power stored and released by inductors, capacitors, etc. So the unit for reactive power is volt ampere. Volt ampere, that is VAR. We call it VAR or VAR. VAR. This is the unit of reactive power. VAR, meaning volts ampere reactive. V stands for volts, A stands for ampere, R stands for reactive. So that we can say apparent power is equal to like 500 VAR, 400 VAR, 1000 VAR, and etc. and something that way. So the last we talk about now is our apparent power. Apparent power is a combination of this duo. This duo means the real power and reactive power defines apparent power. In that case, apparent power is represented with X, which is equal to P, real power, plus Q, which is reactive power. So this is our real power, this is our reactive power. Combination of these two now give us apparent power. So as you can see there. And apparent power is equal to I squared, is equal to IV. Is equal to IV. Apparent power is equal to IV. As simple as that. Then the next thing we are going to look at is classification by phases. Classification by phases. So on classification by phases now, so we are on the third classification, which is 3, classification by phases. Of course, here now we have the single phase circuit or single phase power, single phase power. Then 2, we have the 3 phase power. Okay, on a single phase power, this is the kind of power which the voltage form possess only one dimension. That is, it runs on one voltage waveform. That is on single phase system, and its application is in our residential buildings and people that demand or need a low power or a medium power. Then on a three-phase system is a situation where the voltage waveform runs into three parameters, all of them oscillating at 120 degree apart. They are at 120 degree apart by our drawing. Assuming you have like this now, what it means is that we have, this is A, or let's call this line 1, call this line 2, call this line 3. So you can see 120 degree apart, 20 degree apart. So this very drawing now, as you can see here, there are spaced out. All the parameter, the line L1, L2, L3, all of them are spaced out, and that is why we say that it's three-phase system. So you can see it's three lines. One is single phase. Single phase is only just one waveform oscillating. Then the last and not the least we look at now is the power factor. Power factor is equal to, or is defined as, the ratio of the active power to the what? Apparent power. So if we have it this way, that power factor PF is equal to active power divided by apparent power. And of course, you see that PF, we have active power as IV cos theta divided by our apparent power by mathematical definition is IV. Now, to derive our power factor, we now say power factor is equal to, this will cancel this to give you cos theta. So this is our power factor now giving us cos theta. So this is where we'll stop for today. We'll meet in our next class. Please share this video, let it go viral. Then we keep on picking it edition by edition. Thank you now, and God bless. Bye.